So for problem number 5, it's similar to, if you've been watching other videos, it's similar to what we've done before in the previous problems. Again, my directions are to simplify. Again, though, similar to how 3 and 4 are, all my exponents are positive whole numbers, so I don't have to rewrite in the denominator, and I don't have to rewrite as a radical. What I do have to do is, since I have a power to a power, and a power to a power, and I can't combine these because they're not like bases, I have to actually take the 7 and multiply it by my two exponents. So it's b to this 2 times 7 and c to the 5 times 7. Which then gives us b to the 14th, c to the 35th. Because these aren't any alike terms, this is my simplified answer. Now in number 6, we have different directions. In number 6, it asks us to write the expression in exponential form. Exponential form means I should have something in the exponent. So therefore, I have to change the radical. This is my radical expression. I need to change this. Now notice that 5 is outside the radical. 5 then is going to stay outside of my exponential form. It's not going to be included. What will be, though, is I'm going to start inside the radical with my base, which is j in this case. So I take j to the power of whatever it was initially, 4, and I take that 4 and I'm going to divide it by the radical, the index number of the radical, which in this case is 11. Now, it's just that exponential form. It didn't say anything else. I am done. When we look at number 7, it asks us simplest form. So simplest form is similar to just simplify, just another way of saying it. Two ways to go about this. I believe in class I showed that because everything in here has the exponents, they're all whole numbers, and they're all powers to powers. I've taken this 4, and similar to how we did in number 5, I can multiply each of those numbers by 4. So 2 times 4 for this power y, negative 4 times 4 for this one, all over y times negative 10 times 4. And we can simplify this to say y to the 8th times y to the negative 16th, all over y to the negative 40. Now in simplifying this, my bases for the numerator, y and y, are the same, so that means I have negative 8 plus negative 16. I can actually combine those to say y to the negative 8 by adding, divided by y to the negative 40. Now, when I'm dividing like bases, like I am here with the y to the negative 8 over the y to the negative 40, what I am going to do is I'm going to subtract the numerator. But what occurs when I subtract the numerator is that now I have this double negative, which turns to plus. So really, I have negative 8 plus 40, or y to the 32nd. This is our simplest form. It cannot get any lower. There are no negatives. Finally, in number 8 is another simplifying problem. Now this time it's cube root of 54, m to the 7th, n to the 9th. What we're going to do here is we've got to break down each of these separately. We're going to start with my 54. The two multiples or factors of 54 I think of are 9 times 6. And we can break down 9 to be 3 times 3, and we can break down 6 to be 3 times 2. Now, we are looking for, since it's a cube root, multiples of 3. So I have a group of 3, it happens to be 3. That's going to be important in the end. I'm going to write this all out at once. So then, the next thing I'm going to notice is that I have 7 m's. So 1, 2, 3, 4, 5, 6, and 7. Just like we did with the numbers, I'm looking for groups of 3. I have one group of 3, two's group of 3's. And finally, I have to deal with the n's. And there are 9 of them. 1, 2, 3, 5. Okay, and similar to how we've done the previous two, I have to look for groups of 3's. One group of 3, two groups of 3, three groups of 3. Anything that I've boxed in has to come out. So I have the group of 3 3's. So a 3 comes out in front as a radical. I'm going to look to the m's next. I have 2 m's. I have 2 groups of n's, so that means m squared. And I have 3 groups of n's, which is n cubed. Now, if there was nothing remaining, we'd be done. But I have this 2 remaining down here and this m remaining up here. So that means I have to keep my radical, cube root, and I re-put in the 2 which is left over and the m which is left over. There are no n's remaining, so there should be no n's inside the radical. These are problems 5 through 8 on your review.